We're on lesson 3 of chapter 7, which is 0 and negative exponents. First, we're going to use the definition of 0 and negative exponents. Then we're going to evaluate exponential expressions. Then we're going to use all the properties of the exponents together. First, let's go through the definition of 0 and negative exponents, or the rules that they follow. We have a, which could be any number, to the 0 power is 1. So a, which is any number, to the 0 power is 1, as long as a isn't 0. And the reason behind that is taking something to the 0 power is actually like dividing something by itself. So 7 to the 0 power, for example, is like 7 divided by 7, which equals 1. 0 to the 0 power is like dividing 0 by itself, which we know we can't do. Anything divided by 0 is undefined. So that's why a can't be 0. So 5 to the 0 power would be 1, because that's like 5 divided by 5. Any number to the negative power, to a negative power, is the reciprocal of any number to that same power. So for example here, we have any number to the negative power, or negative n, equals 1 over a to the positive n, as long as a doesn't equal 0 again. Because remember, you can't divide by 0. So for example, if we have 3 to the negative second power, notice how we changed that into 1 over 3 over 2 to the positive power. Then 1 over 3 to the second power would be 1 over 3 times 3, which equals 9. This works backwards then. A to the positive power is the reciprocal of a to the negative power. So for example, a to the positive n equals 1 over a to the negative n power, as long as a doesn't equal 0. So 3 to the second power is the same as 1 over 3 to the negative second. So we see that this works backwards from this. So let's put this knowledge to use here. It asks us to evaluate the expressions. It says 3 to the negative second power. Well, I know from this page that this is the reciprocal of this. So we could do 1 over 3 to the second power. 3 to the second power is 9, so our answer would be 1 over 9. We have negative 7 to the 0 power. Remember, anything to the 0 power is like dividing something by itself. So we have negative 7 divided by negative 7. That's going to be positive 1. Anything to the 0 power is positive 1, including negative numbers. Here we have 1/5 to the negative second power. And remember, if we have a negative power, that's the reciprocal of a to the positive power. So we see how it got flipped with the 1 over and then a to the positive power? We could do the reciprocal of this. The reciprocal of 1/5 is actually 5 over 1. So we'd have 5 over 1, and then we have 5 to the second power here. 1 is to the second power too, but 1 times 1 is 1. So this gives us 25 over 1, or just 25. Now we have 0 to the negative 5th power. And if you remember, we can't do this because the numbers cannot be 0. So we're going to call this one undefined. We're asked to evaluate these expressions. We have 6 to the negative 4th power times 6 to the 4th power. If you remember our product property before, we would add these exponents when we're multiplying. Negative 4 plus positive 4 equals 0. So we got 6 to the 0 power. And we know that any number to the 0 power would be like dividing it by itself. So 6 divided by 6, which equals 1. Now we have 4 to the negative second to the second. Remember, this is the power to a power property. We'd multiply this times the negative second. So that would give us 4 to the negative 4th. So we'd write this times the reciprocal, 1 over 4 to the positive 4. 4 to the 4th power is 256. 4 times 4 times 4 times 4. So we have 1 over 256 as our answer. Now we have 1 over 3 to the negative 4th power. So we could do the reciprocal of this and then make this the positive 4th power. So we'd have 3 over 1, and then the 3 is to the positive 4th power. 3 to the positive 4th power is 81, so we have 81 over 1, or just 81. Here we have 5 to the negative 1st power divided by 5 to the 2nd power. If you remember our quotient properties for exponents, we could actually subtract this number from here to simplify it. So we could do negative 1 minus 2, which would be 5 to the negative 3rd. So now we can write the reciprocal with a positive exponent. So we'd have 1 over 5 to the 3rd. 5 to the 3rd is 125. So 1 over 125 would be our answer. Now we're going to use all the properties of the exponents at one time here in these problems. It says to simplify the expression, give your answer in only positive exponents. We have 2 times x times y to the negative fifth, so y is all by itself to the negative fifth. Then all of that is to the third power. So we can use our power to the power properties and multiply this times each part of this problem here. So we would have 2 to the third power times x to the third power times y to the negative 15th power. If you remember, it tells us to do it in only positive exponents, which means that this y to the negative 15th is not okay. But we could do the reciprocal of y to the negative 15th and make that positive. So if I was still going to rewrite this, we could still keep these positive ones on top, but this can go on the bottom. So we have 2 to the third times x to the third over y to the positive 15th, because that's the reciprocal, and then it's a positive exponent. Then we can simplify this 2 to the third. 2 to the third is 8, so our answer would be 8 times x to the third over y to the 15th. This one looks like it might take a few more steps. So we have 2x to the negative second times y to the fifth. We have negative 4 times x to the second times y to the second. So let's distribute this negative 2 to both. So we have 2 to the negative 2. We have x to the negative 2 times y to the fifth. And that's over negative 4 x squared y squared. So let's move these negative exponent ones down to the bottom by doing their reciprocals. So we'll take this and we'll move it down here. So let's rewrite this problem. We have only y to the fifth on top now, and we have just what we had before, negative 4x squared. We have y squared, and now we have 2 to the positive second, then times x to the positive second. Let's simplify this 2 to the positive second. That would become 4, so we have 4x squared here. We have negative 4x squared y squared here. Remember, we can multiply in any order here, so we could do negative 4 times positive 4. That would give us negative 16. We could do x squared times x squared, which would be x to the fourth. We have y squared right here. So if I'm going to rewrite this problem here, we have this on the bottom now. We have this on the top. So we have y to the fifth on top over negative 16 x to the fourth y to the second. Now we can use our quotient property to simplify this even. So we have y to the fifth divided by y to the second. We would subtract the exponents. That becomes y to the third. Then on bottom we would have just this left, which is negative 16 x to the fourth. So just to recap, we did the power to multiply these, which gave us 2 to the negative second, x to the negative second, that everything else was the same. We got rid of these negative exponents by doing the reciprocal and moving them down here. Then we simplified that, got this answer, and then simplified using the quotient property to get our final answer here. So this will be our final answer.